My name is Mitrano, and I'll be discussing our work on improving data efficiency when adapting dynamics models. In order to efficiently learn a dynamics model for a task in a new environment, one approach is to adapt a model learned in a similar source environment. However, existing adaptation methods can fail when the target dataset contains transitions that dynamics are very different from the source environment. For example, the source environment dynamics could be of a rope manipulated in free space, whereas the target dynamics could involve collisions and deformations on obstacles. Our key insight is to improve data efficiency by focusing model adaptation on regions where the source and target environment dynamics are similar. Our method focuses on regions of similar dynamics by dynamically reweighting the loss for each transition in the dataset. The weights are near 0 if the dynamics are dissimilar, and near 1 if the dynamics are similar. We use the current prediction error as a heuristic for similarity. Since we assume that, before any adaptation, the learned dynamics is a good approximation of the source dynamics, then it follows that low error transitions from the target environment are likely in regions of similar dynamics. In this plant watering example, the pore on the left is dissimilar to the source dynamics because the interaction between the water and the plant is unlike anything in the source environment, whereas the pore on the right does not interact with the plant, is similar to the source environment, and has low prediction error. We also combined the proposed adaptation method with prior work on planning with unreliable dynamics to create a method for data-efficient online adaptation called Focus. In online adaptation, the robot iteratively plans using the learned dynamics, executes the plan, then uses the collected data to adapt the dynamics. This method also uses MDES, which learn where the adapted dynamics are accurate and are used to bias the planner towards regions where the source and target dynamics are similar. We evaluated a method in 2 domains, bimanual rope manipulation and plant watering. In this example, we compare Focus to one of our baselines after one iteration of adaptation. The plans from Focus avoid pouring on top of the plant, since those dynamics are dissimilar to the pouring dynamics in the source environment. By avoiding these difficult-to-learn dynamics, Focus achieves higher success rates with less data. Here we evaluate our method on adapting a model of free space rope dynamics learned in simulation to the real world in a cluttered scene resembling the engine bay of a car. This task mimics putting lifting straps onto the engine. After 15 iterations of adaptation, we evaluated Focus and the best baseline from simulation 32 times. The baseline succeeded 11 out of 32 times, whereas Focus successfully placed the rope under the hook in 15 out of 32 trials. Our method avoids contact with the environment because the contact dynamics are dissimilar to the source environment dynamics and therefore difficult to learn. Please see our paper for additional experiments and results. Thank you.